Yeah, so probability, question 10, here they say more 10.1, A and B are two independent events such that the probability of A is equals to 0.2 and the probability of not B is equals to 0.5. Then we must determine this. So okay, let's just analyze this statement properly then before we jump into answering. Okay, they say A and B are two independent events. So that's very important. So what do we know about independent events? So independent events, that we know that since now we have A and B, so we know that the probability of A does not influence the probability of B happening. That's what we know about independent events. And also we know that for the probability of A and B, we are just going to say probability of A multiplied by probability of B. So for independent events, probability of A and B is equals to what's this? The product of probability of A and B. So basically when we multiply probability of A and probability of B. Sure. So they say A and B are two independent events such that the probability of A is equal to 0.2. So we have the probability of A given to us. And now they say the probability of not A, or not B, I mean, is 0.45. So what does this mean? So the probability of an event not happening, this is now a complementary events. So what we refer to as complementary events, which will lead us to the complementary rule. So let us jump into 10.1.1. Yeah, so 10.1.1, they say determine the probability of B for just 1 mark. Yeah? So we are given here that the probability of B of not B is 0.45. So basically, we will just use the complementary rule to get the probability of B. So what does the complementary rule state? So it just tells us that the probability of B plus the probability of not B is equals to 1. So basically the probability of B happening plus the probability of B not happening is equals to 1. So if now we know that the probability of not B is 0.45, so we will say the probability of B plus the probability of not B is equals to 1. Then to find the probability of B, we will have 1 minus 0.45, which will be 0.55. So therefore the probability of B is 0.55. It's just that 1 mark. Yeah, I hope that was clear enough for you guys. So let us just jump into the second one. Let me make some space here. So now they say 10.1.2, determine the probability of A or B, right? So for the probability of A or B, when we are dealing now with independent events, we look at now the addition rule. Addition rule, which basically just tells us that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. No. Yeah. So already we know the probability of A, right? Our probability of A was given as 0,2. So we will have 0,2 plus the probability of B. We just found it here in the previous question to be 0,55. Yeah. Minus the probability of A and B. So we don't really have the probability of A and B. But as I have mentioned that since we were given that A and B are independent events, we can actually find the probability of A and B by multiplying the probability of A, which is 0,2, with the probability of B, which is 0,55. So if you guys, please just punch this in your calculator quickly and tell me what you get. So 0,2 times 0,55, what is that? So what are you getting there?
0.11.
Please repeat that.
0.11.
0,11, yeah? Oh, so yeah, let me just erase this little part here. Yeah, and let me do this. Okay, that's okay. I will just say now for my probability of A or B, now that's 0,2 plus 0,55 minus 0,11. And then what is the final answer for that? What is the final answer when you say 0,2 plus 0,55 minus 0,1? What do we get? I think it's 0,64, né? Is that what you guys are getting? So that's going to be 0,74.
Yeah, I guess 0.4.
Yeah. Yeah. So basically, that's just our story. You know, independent events. Yeah, it's just a starter, né? It's just a starter. So, you know, usually at the beginning, everything is flowing nicely. But then with a probability, usually you just have to know your theory when it comes to probability, like your complementary rules, your addition rules, independent events, mutually exclusive events, stuff like that. Then you are most likely going to flow through all of the questions. Né? So already we did 10.1.1 and 10.1.2. You're in an exam environment, you're feeling good. So you continue now to 10.2. And now they award you 4 marks for 10.2. And it looks like we have a bunch of information for 10.2, right? So let me just do this. Let's see. So I'm going to have now, okay, yeah, 10.2, let's just read. They say Asanda travels to school on her bike or by taxi. Okay, the probability that she travels by taxi is X, right? So maybe we can do ourselves a favor and write it down. The probability that she travels by taxi is X. Ne? If she uses her bike, the probability that she will be late is 2/5. And if she travels by taxi, the probability that she will be late is a half, né? Or 1/2. Okay, then now they say determine the value of x. Okay, they want us to determine the value of x if the probability that Asanda is not late. So already we see that's a complementary, né? Not late. for school is 8 over 50. So now they give us a complementary, right? So let's try and let me just ask you a question. It has nothing to do with this question here, but it's just to test your understanding. So if they say the probability that Asanda is not late for school is 8 over 15, then what is the probability that Asanda is late for school? You don't have to say that answer, just tell me how are you going to get that answer.
equate the probability late or not late to 1. Then we'll solve for probability are not late. For
Yes.
example.
So basically you will just say 1 minus 8 over 15. Then
Yeah.
you're going to get the probability that she's okay. Yeah. So always just bear that in mind. When you see not late or not whatever, probability of not be and stuff like that. So I don't know if you guys have it has clicked in your minds already, but for this one, we are going to have to use a tree diagram. Yeah? A tree diagram. Simply because now we have more than two events occurring. Because the first event is uh, Asanda traveling to school by a bike or a taxi, and the other one is her being late, right? So we are going to use a tree diagram for them. So let's see. Sharp. So let me just put it here. So at the beginning, they say now what the probability that she travels by taxi is X. So we will have our taxi. No? So the probability that she travels by taxi will be X. All right. So just tell me this. If she doesn't travel by taxi, what does she travel with?
Like a bicycle.
A bike, right? So we will put a bike here. So again, let me give you a clue. To now, using the complementary rule, we know that the probability that she will be traveling by a taxi is X, right? So what is the probability that Asanda will be traveling by a bike? Or let me rephrase. What is the probability that Asanda will be not traveling by a taxi? Maybe it might make sense. So remember, it's the complementary rule. I even said it, I gave you guys a clue. So the probability that you will be traveling by a taxi is X, right? So the probability that you will not be traveling by a taxi is what now? It's going to be 1 minus X, right?
Mm.
Is that clicking, ne?
Mm.
Because of the complementary rule, we know that when she travels by taxi, it's going to be X. So if she's not traveling by taxi, it's going to be what? 1 minus X, all right? Because when we have to now add them, the probability of traveling by a taxi plus the probability of not traveling by a taxi, we must get 1. So sharp. And as I said, if she's not traveling by a taxi, according to what we were given here, she's traveling by a bike. If it's not a bike, it's a taxi. If it's not a taxi, it's a bike. So now the probability now that she will be traveling by a taxi is X, and the probability that she will not be traveling by a taxi is 1 minus X. Yeah? So that's our first event. We're now determining that is she traveling by a taxi or a bike. Then they further on tell us that if she uses her bike, the probability that she will be late for school is 2 over 5. So now we are here at the bike. So what's our second event? Either she'll be late, right? So if she's traveling by a bike, the probability that she will be late, so let's put late, L for late, is what? 2 over 5, right? So we are going to put 2 over 5. Then what's the complementary of being late?
3 over 5.
Okay, yeah, but in terms of the events, if you are
Not
late,
late, okay.
what is the complementary of that? If you are late, what's the complementary of that?
Not late.
Not
Okay,
late, right?
early.
So here we are
Yeah,
going to
can
have not late. Yeah? And then what is the probability of her not being late when she uses a bike?
3 over 5.
3 over 5. So I'm just going to say 1 minus 2 over 5, right?
Yeah.
Then it gives you 3 over 5. Yes. Thank you. 3 over 5. Then they continue by saying that if she travels by taxi, the probability that she will be late is a half. So let's see. Now we are here by the taxi. If she travels by taxi, the probability that she will be late is a half. And for this one, it's obvious the complementary, the probability that she will not be late will still be a half, right? Yeah, good. So basically, we have represented all of this information that was given in a tree diagram. Ne? So we can kind of get everything that we want now. So I'm just going to do something, even though it's not necessary in terms of this question, but it might be applicable to a different question that you might face. Huh? So let me just do it. If now they want the probability of Asanda being late using a taxi. Né? If we have to basically combine everything, we will just have here a T and L. Né? So it's basically when she uses a taxi and she's late, that's TL, right? And here we will have what? When she uses a taxi and she's not late, it will be T and not late. Né? When she uses a taxi and she's not late. Then here we will have when she uses a bike and she's late. So it will be a bike and late. Né? So bike and late. Then lastly, we will have when she uses the probability when she uses a bike and she's not late. A bike and she is not late. So basically, to find all of these things, what are we going to do? We are just going to multiply along the branches. Né? So for T and L, it is she's using a taxi and she's late. That's half X. For T and not late, for using a taxi and not late, we multiply it. So that's X times a half. So you see what I did here, né? We multiply the X times a half. Even here, for using a taxi and she's not late, that's what? X times a half again. So that's half X again. Né? Then the probability now that she uses a bike and she is late, that's going to be what now? 2 over 5. Look, it's going to be 2 over 5 multiplied by 1 minus x. Do we see that, ne? So we just, since it's a tree diagram, these lines here that we draw, we say they are branches. So we just multiply along the branches, basically, ne? That's what we are doing. Then the last one will be the probability that she's using a bike and she's not late. That's going to be 3 over 5 multiplied by 1 minus x. Yeah? So that was that. So now if they say, what is the probability that she uses a bike and she's late? No, she uses a taxi and she's late. Please listen carefully. What is the probability that she uses a taxi and she is late? Yeah. And she uses a bike and she's late. What is that probability? Let me repeat it again. What is the probability that she uses a taxi and she is late? And then she uses a bike and she's late. What is that probability? So then, already we know it's this one and this one, right? So she uses a taxi, she uses a bike, and she's late. So what we are just going to do now, again, we know when we go along the branches, horizontally we multiply. So when we go down now, or vertically, we add. Ne? So to see that she's using a taxi and she's late, and she's using a bike and she's late, it is now, it will be 1 over 2 plus 2 over 5, 1 minus x. Ne? So like, even though that's not possible, ne? That's not possible because you cannot use a bike and be late. You cannot use a taxi and be late and use a bike and be late at the same time. So you must either use one. You can either use a bike or you can either use a taxi. So like you can't use a bike and a taxi at the same time. You get that, ne?
Yeah.
So these two events, they can't happen. They can't happen simultaneously, or they can't happen at the same time, right?
Yeah.
So if they can't happen at the same time, that's when we are talking about mutually exclusive events. Yeah. So basically, mutually exclusive events is events that cannot happen at the same time, right? So, and I'm just giving you guys some extra information here. It's not relating anything to our question. But then with mutually exclusive events, we know there is no intersection, né? Meaning there is no probability of A and B, for instance, if you are using events A and B. So probability of A and B will always be equal to 0 if we have mutually exclusive events, right? So if now we had to get the probability of A or B, we go back to the addition rule and get which is probability of A plus probability of B minus probability of A and B. In this case, if we have mutually exclusive events, we know that the probability of A and B is always 0, right? So that means for mutually exclusive events, the probability of A or B is just what? Probability of A plus probability of B. Do you see that? That's just me playing around with the information and just showing you. But then, okay, let's go back to the question. No? Let's go back to the question at hand. So let me just fix this diagram a bit so you can see it properly. Let's see. Erase this. Let's just erase here. Also here. Nope, 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 nope. Okay. Erase here, here, here. Nope. Erase here. Okay, yeah. Let's see, guys. Yeah? So we have our tree diagram. Let's just analyze it one last time before we answer the question. Yeah? So here we know that going here, we have the probability of using a taxi and becoming late, the probability of a taxi and not being late, probability of using a bike and being late, then the probability of using a bike and not being late. So now they say determine the value of x if the probability that Asanda is not late. Ne? not late for school is 8/50. So now what we are given now, this 8/15 relates to what? Not late. Okay. They'll start there. This 8/15 relates to not late. So to get basically the value of x, we will use the information whereby Asanda is not late. And the first one is when she's using a taxi and she's not late. Né? This one here. And the second one will be what? When she's using a bike and she's not late. Right? So taxi and not late, bike and not late. And as I said, along when we go vertically, we add now. Né? So
Yeah.
the probability that she's using a taxi and she's not late, that's going to be x times a half, right? X times a half, which will be now, okay, now I'm answering that. So pay attention. It will be 10.2 half x. That's when she's using a taxi and she's not late. And then we are going to add it with what? When she's using a bike and she is not late, which will be 3/5 multiplied by 1 minus x. So 3/5 multiplied by 1 minus x. So these are the only instances where she's not late. And we know that the probability of her not being late all in all is what? 8/15. Né? Is that making sense? Né?
Yeah.
Sure. So once we are there now, it's going to be the situation of what? Just going through everything mathematically and just trying to solve for x. Then, so we will have a half x plus. So we are just going to distribute this 3/5. So we'll have 3/5 plus, no, it's actually a negative because positive times negative is negative. So it will be minus 3/5x, which will be equals to 8/15. So now, what is half x minus 3/5x? Let's start there. Please punch it in your calculators quickly. Half x
minus 1 over 10.
So we'll have minus 1/10x. And then what will be 8/15 minus 3/5?
Minus 1 over 15.
Minus 1/15. So to get x, we will just divide both sides by 1/10, by negative 1/10 to be specific because we have a negative. Then here it will cancel, then we'll have x is equal to. So what is this now? Negative 1 over
2.
What do you get?
2 over 3.
2/3. So now here's our value for x. 2/3. So you see, it's not that hard, né?
Yeah.
Yeah, understandable. Are we all good? Tsebo, how are you doing? Is it good?
Yeah.
So far so good, né?
Yes.
So let's continue. We are going to question 11 now. Yeah, we are done, né? So you did your question 8, it was just a nice, you did your question 10, I mean, it was just a nice 8 marks. You've collected your 8 marks. Now you're going to question 10 to collect even more marks. Yeah? So that's the kind of confidence you must have when you're in an exam. Let's look here now. Question 11, what are they saying to us? They are saying, in a certain province, vehicle number plate codes have the following format. Yeah? So it's at, and then hashtag. Then they say 3 letters followed by 3 digits. So here are my letters and here are my digits. Where at represents a letter of the alphabet. So yes. And then a hashtag, a digit from 0 to 9. So they say for each number plate code that is assigned to a vehicle, the following conditions must be met. So they are giving us restrictions. Ne? Let's read the restrictions. All letters except E, G, and O can be used, and no letter can be repeated. So this is very important. Ne? When they say no letter can be repeated, that's very important. So, okay, we've taken that into mind. Then they say now, no number plate code can start with a vowel. So now they are taking us back to primary school. You know our vowels are, what do we say? R, A, E, O, U, right? It's just those are our vowels. So a number plate can start with a vowel. And then okay, we took note of that. And then they say all digits can be used and each digit can be repeated. Okay, that's nice. Now we have read our conditions. We can go to the questions now. Now they say 11.1. How many vehicles can be assigned a number plate code according to this system? So meaning according to the restrictions that we were given. Yeah? So basically, this is still probability. What we call this now is counting principles. Ne? This is counting principles. So we usually use counting principles when we have large possibilities or probabilities, large outcomes basically. So how many vehicles can be assigned a number plate to according to the system? So let's just look at it quickly. So I'm just going to make, here's my 11.1. So I'm just going to make 6 blocks. Ne? 1, 2, 3, 4, 5, 6. So we know my first 3 blocks represents the letters and my last 3 blocks represents my digits. So let's go to the restrictions. So they say all letters can be used. Ne? So we know according to the alphabet, we have 26 letters, right? And then they say all letters except E, G, and O can be used and no letter can be repeated. So except these 3 letters, ne? So meaning we can use all of them except these 3. Meaning now out of the alphabet, all of the letters of the alphabet, we can only use 23 letters, right? And then they say no letter can be repeated. Now they say no number plate code can start with a vowel. So meaning here, we are focused here at the beginning. So our vowels are what? A, E, O, U. Ne? But then take into considerations that here they said E and O is out. Ne? So already we took it out here on the 23. So there's no need to take it out again. So at the beginning now, for the first one, I have only 23 letters, but I can use A, I, and O, right? So it will be what now? 23 minus 3, which is 20. So for the first letter, I can only use one of the 20 letters. Ne? Are you catching me there? Ne?
Yeah.
And then now, since they said no letter can be repeated, since I used 20 letters, that means whatever letter that I use, let's say for the first letter, I use N. That means N must be removed ne, going further. So since I used one letter, that means I must say 20 minus 1. Now I'm left with 19, right? I'm left with only 19 letters now. And I know that out of the 20 that I used, none of them was a vowel, right? So I must add them back so I can use them for my second and third letters. So now it will be 19 plus the 3 that I took out. Then how many do I have now? 22 that I can use. Yeah? So for the second one, I can use 22 letters. Am I not losing you? I hope I'm not losing you guys, né? Because I'm moving a bit fast. But yeah, I'm just going according to the the restrictions. I'm just going according to that. So now I have access to 22 letters here, right? Then out of that 22 letters, I'm just going to use one. Then after using it, I have access to how many now? 21. Because whatever letter that I used, I can't use it again. That's why I said this information is important when they say no letter can be repeated. So for the third one, I only have access to 21 letters that I can use. Yeah? Then I'm done with the letters now. I'm done with the letters because it's 3 letters, 3 numbers. Let's go to the digits. They say all digits can be used. Né? So either digits from 0 to 9, and each digit can be repeated. So now from 0 to 9, let's count. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 digits that I can use because 0 is included. Né? So I can use either 10 here, right? But then since they said they can be repeated and all of them can be used, so it means everywhere I have 10. So to just find everything, how many letters I can, to find my answer, I'm just going to multiply everything out. So it's 20 times 22 times 21 times 10 to the power of 3. What is that? What is the answer?